Okay, let's have a look at change of parameters. Now, the first thing to note with the change of parameters, because of this, it means because there's a combination of two different things, exponentials and x to the power of 4s or polynomials, it's very hard to have that guess about what our general solution or our particular solution is going to be, So this is when we tend to use the change of parameters. So the first thing we're going to do if we want to solve this and find a general solution, so the first thing we're going to do is we're going to consider our homogeneous solution, y double dash equals 2y dash plus y equals 0. This is fairly standard, the way we do these, and therefore if we look at lambda minus 2 lambda plus 1 equals 0, lambda squared minus 2 lambda, what we get is that lambda minus 1 all squared equals 0, therefore lambda equals 1. Now this is one of those cases where, our first solution, our complementary solution, is c1e to the x plus c2e to the x, but these wouldn't be linearly independent. So what we have to do is make this and the second solution, or y. So if y1 equals c1e to the x, then y2 equals c2x e to the x. So that's our first thing that we have to be aware of. This is one of those cases where we need linearly independent solutions, so we've got to put an x in here. That's our first step. So that's part of our complementary solution. Now, to do this change of parameters, or yp, the particular solution is going to be minus y1 times the integral of y2 times f of x all over w, which is the Wronski, the determinant of the Wronski, and the second one plus y2, the integral of y1 f of x over the Wronski again. So f of x is just this. This is f of x, or this is our f of x. Okay, this is going to be our y1, and this is going to be our y2. So the first thing we have to work out is the Wronski. Now, remember, to look at the Wronski, it's our y1 e to the x and x e to the x, and the second line of it is going to be the derivative. What's the derivative of e to the x, e to the x? What's the derivative of this? Well, it's x e to the x plus 1 e to the x, because it's a product. Probably better to write that out a bit nicer, as in e to the x, e to the x, x e to the x, and this becomes 1 plus x e to the x. Probably a bit nicer and a bit easier for the next thing that I'm going to do, to write it out like that. Now, what we want for our Wronski is that we want the determinant of this. So it's going to be this times this, which is e to the x times e to the x outside of 1 plus x, minus the other one, which is going to be e to the x times x e to the x. And if we expand this all out, we're going to get e to the 2x times 1 plus e to the 2x, or x e to the 2x, minus this one becomes x e to the 2x, and nicely these two things cancel out. So our determinant, our w, is e to the x. Now we've basically got all the things we need to substitute into here. So our particular solution, and we'll take it all up here, our y particular is going to be minus y1, the integral of y2, f of x over w, plus the integral of y2, and we'll start a new page. Our y particular is going to be minus y1 times the integral of y2 f of x over the Wronski plus y2 integral of y1 f of x over the Wronski. So substituting all of that in, our y particular, if we go back, y1 was minus e to the x, or e to the x, times the integral of x e to the x. We've got to times this by our f of x, which was e to the x over x to the power of 4. And we're going to divide all this by our Wronski, which was e to the 2x, plus x e to the x, multiplied by our y1, which was just e to the x, times e to the x over x to the power of 4, over our Wronski, which was e to the 2x. Now that looks horrendous. I understand that looks horrendous. It's just the way it is. But most of this cancels out, and this will tend to happen. If we multiply these, we get x to the power of 3 on the bottom. This becomes e to the 2x at top over x to the power of 3 over e to the power of 2x, which is nice because these two will cancel out. Plus over here we get x e to the x, and what cancels out here, this is going to be e to the 2x over x to the power of 4 over e to the 2x. Check to see if that's what I got last time. Yep. So what this becomes is, or what we end up with is, minus e to the x outside of 1 over x cubed, which is x to the power of minus 3, plus x e to the x, x to the power of minus 4. So it did look horrible, but it sort of worked out fairly nicely. Integrating this, you get minus e to the x, x to the minus 2 over minus 2, plus x e to the x times x to the minus 3 over minus 3. So suddenly we've started looking at something that's getting down to something a bit more nice. Here the minuses cancel, and so we're going to be left with e to the x over 2x squared, plus the x's can cancel here, so we're going to have e to the minus 2 as well, so we're going to have e to the x over 3x squared. That should be that should be a minus in there, sorry, because you're still going to have that minus there. And suddenly we're starting to get something that's fairly nice. We can add these indices fairly quickly. We're going to have 3e to the x, 3e to the x, minus 2e to the x all over 6x squared. So our y particular equals e to the x over 6x squared, which, even though it looked as though it was going to be horrible, it did turn out to be nice. So our general solution, which is what we want, y general, is going to equal our first solution, c1 e to the x plus c2 x e to the x, plus our particular solution, e to the x over 6x squared. And that's it. I shouldn't say that's it. but that's how we come to the Wronski. It